So in today's video, we'll talk about wide area network, load balancing or failover, automatic failover without depending on the traditional routing protocol. In the traditional routing protocol model, your router, the WAN edge router in this scenario, the user is sitting here and he's going to his internet router in the company, and the internet router is peering with service provider 1 and service provider 2 and trying to reach a destination on the internet. And until a routing failure happens between these two, it would not converge. What if the routing stays up and there is something wrong in the cloud of the service provider, right? Either packet loss, latency, some kind of a connection failure. What happens then? There are features in different products, but in this case, we'll talk about VYOS. What does that support? Because it's open source and free to use unless you want to buy the support. So here in our setup, we have these VYOS routers, and this guy is you sitting in your company and running a ping to the destination, and that destination address is, in our case, going to be 104.4.4. This is our internet destination that we're trying to reach, and initially we want to prefer this path. This is Ethernet 0 and this is Ethernet 1. We'll see the configs, but we want to prefer this path. If something goes wrong with this path in terms of latency, or if there's a disconnection in the network in this service provider, then we will automatically switch to this guy without waiting for the routing protocol to converge. In our case, we're just using static routes, but you can use OSPF, BGP, whatever you want. But we don't want to depend on that, but we're using static routes all the way across, and we will try this out to see how this feature called WAN load balancing works on this router. So here in this case, V1 clone is this router right here. We're going to run a bunch of pings, and V1, which is the edge router, is going to be this router here called the Corp edge router, and V2 is your service provider 1, and then your V3 here is your service provider 2, and this is your internet destination. We will play with the, add some latencies, packet loss or latency here, and create some faults on this link to see how this path converges. Okay, so let's get this going. If we were to ping this guy, we'll see that there's a latency of 3 seconds or so. Right now, I have not. This guy is configured with 0 latency, and this guy is configured with a latency or network delay of 100 milliseconds. So he's taking this path right now, the preferred path, and I'll show you the configuration to see how you do that. He's taking this path, which is the preferred path. So the wait for this link is, let's say, 255 that I've configured, and wait for this guy is 1. He will only switch to this guy when there's something wrong in this cloud or some failure happens here. So let's create that latency. So he's going through this path. Let's make sure that he is by doing a trace route. And yes, he is 12.1.2. He's going through this path. So restart our pings. He's taking around this much time. Now, if I were to create some latency here, let's just say 2000, because I've configured this guy with a switchover threshold of 1 minute, and I cannot go any minimum less than that based on the configuration or support, software feature support. So 1 minute means I have to go above 1000 milliseconds. So let's just say 2000 milliseconds, which is 2 minutes. Keep an eye on this guy and watch what happens here once I do a commit. Now watch here, 2000, and immediately he evaluates, and he switches to this guy. Remember, this guy's 100 milliseconds, so he's now on this path. He immediately switches to this path to reach his destination 104.444. This is this guy right here. And he's simply configured with static route, equally static routes, and his loopback is 104.44 loopback. Okay, so what happens if this latency goes away? So let's set it to 0, commit, and watch. He's going through this path, latency of 100, right? And keep an eye on this guy. You should switch back to this guy. There you go. His latency was 100 and our limit was 1 minute, so we set this guy to 2000 milliseconds, which is 2 minutes. And so temporarily he switched here until the problem got resolved and he switched back to the original path. And now what happens if I create so this is just latency, you can do packet loss as well. Let's see if you were to introduce a failure on this path here, right? This path. So we'll do this by disconnecting this network. So let's say this network is 24. We go and we say cable not connected. Okay, he's gonna stop because he's taking this path and immediately switch, if not immediately, eventually 104, he's switching to this path now. So he switched automatically, even though the routing is statically configured for both these routes or both these paths. Reconnect him. Cable connected, and he should switch back to lesser latency, back to this path, which is 0 delay right now. There you go. So this configuration, this feature set is called WAN load balancing, and I'll show you the configuration for this. It's pretty straightforward. This is how you configure the WAN load balancing. You basically disable, it's not disabled by default, so you have to disable the source NAT. You have to use the flush connections command to make sure this is dynamically done. And these are the egress interfaces, E0 and E1. So this is E0 here, E0 and E1. So I'm going and checking the interface health for these, and I'm saying failure count is 1 for both. This is my next hop right here, and next hop for Ethernet 1 is this guy. And I'm saying the response time is 1. This is the minimum it supports, 1 second, and I'm saying target 104. So you can, establish any flow based on destination. In this case, it's 104 that we're testing, and the way he tests this path is using ICMP or pings. You configure exactly the same, and then you have to configure a rule saying rule 1 destination is this guy, and again, each destination could be different, or you can use quad 0 for all the traffic. Your inbound interface is going to be Ethernet 2. In this case, this is the inbound interface. So you got to have an inbound, you got to have 2 egress. 1 ingress, 2 egress. And you got to specify the weight, saying that I prefer E0. So this guy is 255, meaning I want to always prefer this service provider. And this is my backup. So in this case, you see this is going 255 with weight 255, and the second link is weight 1. You choose protocols all, or whatever you want to, whichever application you want to do this for, and that's about it. And this does the magic in this free open source router called VYOS that we've been using and testing. It's called WAN load balancing, and here's the scenario that you can use to test it. Hope this helps.